Hello friends, welcome again to this channel. We find solutions for your needs in this channel. And today we are to determine the ratio of the line current drawn by three identical impedances connected in Y. The line current drawn by the same impedances connected in delta, both connections being impressed with the same balance three-phase voltages. Okay, so it's just a matter of finding or determining the ratio of the line current. When you have these three identical impedances connected in Y or in delta. So the first thing that we should present is the Y connection. How about if you are to connect this impedances, same impedances into Y. So let us have this illustration. Okay, so this is the illustration. This is the impedance. Let's say, since these impedances are the same, let us have ZP, ZP, Z sub P. Okay, and these are the terminals. So if you are going to solve for the phase current here, I sub P, okay, and the line current also is here out at the terminals. Okay, so to be able for us to get the line current, you know that the line current here is equal to the phase current. So the phase current can be solved by using our Ohm's law, which is the phase voltage. I am using, let me just use B sub P over Z sub P. Okay, so that is the value for your phase current. But since that we are looking for the ratio of the line currents in Y connection or to the delta connection, so let us have the equation in which it is expressed in line connected variables. So BP, or the B phase for this setup, which is Y connected, is equivalent to the V line over square root of 3, since that our BP in Y is actually we have this relationship, okay, in which V sub L over square root of 3, or we have B sub L square root of 3 BP. Okay, and this one is our value for B sub P, and it is substituted here. So that's why we have BL over square root of 3 over Z sub P. Okay, and since that we are to simplify this term, our IP or IL is now B sub L. Okay, to simplify, this will be on the denominator, square root of 3 Z P. Okay, so again, your IL is equals to IP, which is B sub L over square root of 3 times the impedance of the system. Now, if you're going to connect all these impedances into a delta connected system, so this is the illustration. Okay, this is ZP, this is ZP, and this is ZP. Okay. Okay, again, your IL will be here, and your IP will be here. And your B sub L is the terminal voltage here, and your B sub P is the voltage at this phase. The phase voltage here of this coil or this rectangle or your impedances. Okay, that is the B sub P. So connecting it into delta system, your B sub P equals B sub L. So the voltages in phase and line voltage are equal. What are the different variable? The different variable is the line current and your phase current, which gives you the relationship that your line current is equal to the square root of 3 times the phase current. Okay, so therefore we are to get the line current here, and the line current. Okay, so this is now in this equation is in Y, and I am looking now for the delta connection value of your line current. So that is actually square root of 3 BP. Okay, so yeah, okay, but I'm sorry, this is actually not B sub P, but this is I sub P. Okay, so this is I sub P, I'm sorry. Okay, so okay, and knowing this relationships, you know that BP is equals to VL, and we use again the Ohm's law, which is IL. So we are solving for first, let us solve for the IP or the phase current here, and that will be B sub P over Z sub P. Okay, and your B sub P is actually equal to B sub L, so it will give you B sub L, which is equals to, over Z sub P equals to I sub P. And then we will now use this one. So IP is actually equal to I sub L over square root of 3. So if you are going to substitute it here, IP is I sub L square root of 3. That will give us B sub L Z sub P. I am taking B sub L because we want to have the relationship of the IL in Y, and let me just write here ILY and IL in delta. Okay, so I sub L in delta is equals to the square root of 3 BL over ZP. So what is now the relationship or the ratio for these identical impedances connected in Y and in delta, considering the line current? So the ratio will be ILY, okay, IL, the line current in Y connection is to the line current in delta connection. And what is that? The line current in Y connection is the line voltage square root of 3 Zp over the square root of 3 voltage, the line voltage divided by Zp. Now we can perform here cancellation. So we can cancel out Zp and Zp, and also BL and BL. So what remains is this one. So for IL is 2 IL delta. Okay, so what remains is square root of 3. Okay. This is the denominator. 1 over square root of 3 is 2 square root of 3. Okay. So what will happen? Okay. So this one will give us this will become this will be divided, and what will happen, that will be 1 square root of 3 times 1 square root of 3. Okay, and will give us 1 square root of 3 squared, or 1/3. Okay, so the relationship of the line current of the impedances, of the same impedances connected in Y and connected in delta, is 1/3 this one. Okay, so that will be the relationship of that two. So thank you so much for watching this